as the question says, figure shows two blocks A and B, each having a mass of 320 grams, connected by a light string passing over a smooth light pulley. The horizontal surface on which the block A can slide is smooth. The block A is attached to a spring of spring constant 40 Newton per meter, whose other end is fixed to a support 40 centimeters above the horizontal surface. Initially, the spring is vertical and unstretched. When the system is released to move, find the velocity of block A at the instant it breaks off the surface below it. Now, breaking off means leaving the surface, which also means that the normal reaction becomes zero at that moment. So we can show it as a position where there will be mg force in the downward direction, and the spring will be like this, that is at an angle of theta. So obviously this angle will also be theta by alternate interior angles, and at that point the normal reaction becomes zero. So we can write it down as kx cos theta actually becomes equal to the mg force, right? Putting the values over here, that is we are having cos theta equal to mg by kx, giving us x equal to 0.1 meters. Why? Because we have the mass equal to 0.32, k equal to 40, h equal to 0.4 meters, and g equals to 10. So we can easily find out theta also by the triangle, and so it gives us x equal to 0.1 meters. Now let us find the distance s moved actually. So that s distance will be under root h plus x whole square minus h square, that is 0.3 meters. Now friends, let us employ the work energy theorem for this problem over the blocks, that is the system of the block. So the change in the kinetic energy will be equal to the total work done upon the blocks. And what will be the kinetic energy change? That will be ma Va square plus half mb Vb square minus 0 equal to the work done. Work done will be mgs, because this will be going s meters downward, minus half kx square. Now this will be minus because the spring has been expanded by x distance, so there will be half kx square energy stored in the spring. That means half kx square work has been done over the spring, which means that a negative of that work has been done over the system of these two blocks. Now here we have been given ma equals to mb. Also we know that in the downward direction this va and the vb will be same, because the spring is inextensible, right? So we will be taking va equal to vb. Why we haven't taken this va in some other direction also? Because there will be no component of va in the perpendicular direction. Why? Because at this point mg becomes equal to the spring force component. In all these intermediate points, mg has been more than the corresponding component of the spring force. So there has been no instant where the acceleration of this block would have been upwards. And since there has been no acceleration in the upward direction and the initial velocity in the vertical direction is 0, so at this point also there will be no vertical direction force, right? So only speed or the velocity will be along the string, and that needs to be equal for both the blocks A and B. Putting that is VA equal to VB over here and MA equal to MB over here, we get 0.32 V square equal to minus half into 40 into 1 square plus 0.32 into 10 into 0.3, giving us a velocity of 1.5 meter per second. So this is the velocity of block A at the instant it breaks off from the surface, that is, it leaves the contact with the surface.